We shall now take a look at a flowchart to generate the Fibonacci sequence. But before we go about generating the Fibonacci sequence, let us first try to understand what is the Fibonacci sequence. So this is the series 0, 1, 1, 2, 3, 5, 8, 13, and it keeps going on. There is no end or termination to this particular sequence. The only two numbers of the sequence which will be given will be 0 and 1. So the next number is 0 plus 1, which is 1. 2 is the sum of the previous two numbers. 3 is the sum of the previous two numbers. 5 is the sum of the previous two numbers. So now if you look at it, let me call the first one first, the second one second, and whatever we calculate, we call it as current. So this 0, 1, 1, 2, 3 are known as terms of the series. The first term is known as first, second term is known as second. Current is going to be the sum of the first plus second. So only these two are given and then you have to generate everything. Now what happens is user is going to enter a value of n. We need to see that as long as the value of current is less than or equal to n, I need to keep generating these sequence of numbers. So let's try to draw a flowchart and try to figure out how we can generate this particular series. So as usual, we will have the first one as start. And as I told you, I'll be requiring first and second. That is the only one I shall be using. So let me do one initialization. Let me say first is equal to 0. Let me say second equal to 1. And let me say current equal to 1. Alright. So this is, I'm just doing it. You'll know why I'm using this particular logic. How long should I keep running and printing the value of current? As long as the value of current is less than or equal to n. So the very first step before you go ahead to print any numbers, you should always know what is the condition to halt. But I am first going to start printing first and second because these are always present in the series. So I'm going to say print first, comma, second. All right. I am printing first and second. So it's going to print 0 and 1 every time. Now I'm going to come and ask a condition. How long should I keep generating the terms of these series? Terms are 1, 2, 3, 5, 8, 13 and so on. So I'll answer that question with this particular condition. As long as the value of current is less than or equal to n, I am going to continue to print the value of current. If it is no or false, I am going to do a halt to this processing and stop. So if current is less than or equal to n, it is true or yes. So what should I do? First thing is I'll go ahead and print current. Okay. So I'm going to print current. Once I print current, then I have a few other things to do. If you see here, next time 2 is the sum of the current value plus the previous value which happens to be second. What it means is first will take the value of second, second will take the value of current, and current is the sum of first plus second. So let me do like this. So now what I'm going to do here is I am going to say first is taking the value of first is taking the value of second, second is taking the value of current. Okay, this is second. All right, and current new value is going to be equal to first plus second. Just in case this is not clear, let me write second because sometimes you may not get it. All right, so this process keeps happening. Now how long should this particular calculation happen? As long as the value of First is less than current. All right. So now let's try to understand this flowchart by trying to do a little bit of testing. That's how only we are going to understand whether our logic happens to be correct or wrong. Now, initially this number is 0, this is 1 and this is 1 according to this step. Now, if you have noticed, I have missed one thing. I have forgotten to read current. So before printing first, I should have done one step here. Now I'll just do a kind of a jugaad here. So, right. So I'm going to say, so that is why it's important to test. I'm going to say read n. Okay, n I have forgotten to read. And after I read n, I'm just going to connect back here. I can just connect back here. So, okay, I'm just showing a rough one. So this read n will come after this rectangular box. I'm reading n. So I am printing first and second. So the output is going to be 0 and 1 is being printed. Now let's take the value of n. Let us say the value of n happens to be 13. All right. Current is 1. 1 is less than or equal to 13. This condition is true. Since this condition is true, I am printing the value of current, which happens to be 1. So I have printed 0, 1 and 1. Now first takes the value of second. So think of this moving like this. This becomes 1, this becomes 1. Second goes to first, current goes to second, and current becomes first plus second. Now this becomes 2. 2 is still less than or equal to 13. So I am printing the next value happens to be 2. Now again there is a shift. Alright. Second takes or gives its value to first. So this fellow becomes 1. This fellow becomes 2. Now current is equal to first plus second. This becomes 3. You're seeing these steps. I'm doing it here. Now current is first plus second. It is 3. 3 is still less than or equal to 13. So it prints 3, not 13. It prints 3. I come here. Now again there is a shift. Okay. Second goes to first, current goes to second, and current is first plus second. This is 2, this is 3, and this is 5. 5 is less than or equal to n. Print current. So if I am printing after 3, the next value is 5. Now 5 is still less than or equal to 13. Alright, so I have printed current and I have come here. Now after printing current, I am again doing this exchange here. This again moves here. This moves here. This becomes 3. This becomes 5. Current becomes 8 according to this particular logic. Now what I am going to do here is 8. 8 is less than or equal to 13 is true. I am printing 8. Alright. Once I print 8, again I have to do this copying around. This becomes 5. This becomes 8. This becomes 13. 13 is still equal to 13. So we are okay. So it will print after 8, it will print 13. Now again when we move, this fellow first becomes 8. Second becomes 13. Current becomes 21. 21 is less than or equal to 13 is false and I'm going to stop. So this is the logic how you should go about trying to verify how to generate the numbers in a Fibonacci sequence. Unless you take a look and do it on your own and draw the table, you're not going to learn logic. Logic is not going to come by seeing it. You have to put an effort to do simple flowcharts on your own. And after you do a few, maybe there may be a struggle of a day or two, but once you do it, you'll find it very easy and interesting.